Hey everyone. So here's a question. What happens when your Spark streaming job crashes in the middle of processing a batch? Why does it not lose the data? Does it write everything twice? How does it not create duplicates? And more importantly, what's the recovery mechanism? Today, we are going to dig deep into how structured streaming actually works. Let me set the stage for everyone. What does the checkpoint look like? If you open any structured streaming job, you'll find a checkpoint. And inside the checkpoint folder, you will find 4 to 5 folders. For the purposes of today's discussion, we only need to talk about the metadata folder, the offsets folder, and the commits folder. Okay. So, first things first, metadata folder stores the query ID. This is your Spark Streaming query ID. You can find it on Spark Streaming UI in your notebook and inside this metadata folder. And then you have to worry about two folders, offsets folder and the commits folder. Let me explain what happens in a normal scenario. When you restart any structured streaming job, it checks the offset folder and tries to find the latest offset file. And these are numbered files. So 012 till infinity, right? So let's say it finds the offset end file. Once it finds the offset end file, then it goes and checks out the commits folder. And then it checks, hey, does the commit/end file exist? If it exists, then it knows that the batch n completed successfully, and then it can go ahead, creates the offset n+1 file. So think as creating offset n+1 file as the intent that it's going to process the next batch. Once it writes the commit n+1 file, that shows that it's completed. So offset is the intent and commit shows that, hey, I finished processing the n+1 file. This is the how Spark streaming works. Very simple to understand, right? Now let's talk about more complicated scenario. Say you killed your structured streaming job. Say you killed the driver, you lost a node, whatever happened, a crash happened and your cluster died. Let's talk about a scenario when that happened. So let's say you have you started processing offset n+1. Again, intent. This is the intent. We are trying to process these offsets. We wrote the output to the target table and the cluster died before we were able to write commit n+1 file. How does Spark streaming then avoid duplicates when writing to the target delta in our scenario? When we try to write into a delta table, structured streaming is going to figure out what is my query ID from the metadata file. It's going to figure out what's my epoch ID. Think epoch ID, batch ID as the same thing. And then it's going to check the delta log or the delta table. Has this combination been written before? If the answer is yes, then it's just going to skip writing because it's going to realize, hey, I have already processed this batch ID for this structured streaming job. So that's the magic on how it avoids writing duplicates into the delta table. Let's talk about the end-to-end scenario. Say you had a failure and restarted your structured streaming job. This job restart on the same cluster, another cluster, whatever, doesn't matter. When we restart the job, it's going to find that n+1 offset was the last offset written. Does commit n+1 file exist? If it exists, this is our happy scenario. We move on to n+2 offset. If it does not exist, attempt write to delta table. And then we go and check, is this structured streaming query ID and batch ID/epoch ID, has it already been written? If it's already been written, then skip because the data is already there. And if no, then write the data into delta table. And then our life continues. It's that simple. There's a blog attached to this video. I have also found an incident where even this wasn't sufficient. It's an interesting issue I landed up with. Have a read on the blog on how I solved that issue. Another thing I wanted to talk about, just some small detail, is the offset folder actually contains information about till which offset it's trying to process. Example, let's say in our offset n, we wrote start offset as 100 and end offset as 200. So when we process the data, the end offset is exclusive. So we are going to process 100 to 199. And when the next batch runs, say n plus 2 batch runs, we're going to process from 200 to 299, assuming we are processing 100 offsets. Just a small level of detail that the front part is inclusive and the end part is exclusive. If you're looking for more details of what exactly is stored in the checkpoint, I have a whole video on that. I'll leave a link to that in the description of this blog. There I talk about each of these different folders, what do they contain, stuff like that. Okay, some extra details I wanted to show you. If you open your Delta table history, you're going to find the query ID, which is your structured streaming query ID and epoch ID in the Delta table. You'll find the job run, which wrote the Delta table version in your Delta tables history. All this information gets logged. Another small mention, it does happen that you have to do deletes on Delta table sometimes, right? Say GDPR and stuff like that. So I have a whole blog on it. Go check it out. Next week, we'll talk about something interesting. I created my first AI agent on Databricks using something called Agent Bricks. I'll tell you how I did it and how you can do the same. It's pretty simple. Honestly, it's more simple than I thought it would be. Keep an eye for the next video.